Hello, in this video we will be exploring how to reverse a singly linked list using a iterative approach and also compute the time complexity and space complexity of the solution that we build in JavaScript during this session. Before we jump into the solution aspect of it, let's just first try to understand what a singly linked list is, and then we can explore the solution aspect of it. We have a linked list node that will have two parts to it. The first part is the value, let us say 1 for this example, and the second aspect is the next pointer, which will either point to another node, which can be 2, or it can point to null, which will say that it is the last node in the linked list chain. If we have an input that looks something like this, with 1 pointing to 2, 2 pointing to 3, 3 pointing to 4, 4 pointing to 5, and 5 pointing to null, the visual representation is something as follows. We have a head pointer that will point to the first node in the linked list, and the last node in the linked list will always point to null. As part of this solution, what we need to do is, when we reverse, the last node, which was 5 in this case, needs to become the first node, and then the connections need to be reversed with 4 pointing to 3, 3 pointing to 2, and 2 pointing to 1, and 1 pointing to the null pointer, which will indicate that this becomes the first node, then this becomes the last node, and the connections between them are also changed. That is the output that we are looking for. As we said that in this solution we will be using an iterative approach. Reverse a linked list using iterative approach. To reach a solution, we will need a loop because we keep on iterating, and then at the end we will return the solution, which is going to be the pointer pointing to the element having value as 5, which is our current last node that will become the first node as we build the solution. To solve this problem, we will be using two pointers. As inside algorithms, there are usually concepts like two pointers, sliding windows, dynamic programming. To the solution that we are building, the pointer approach seems quite feasible. So I will proceed with that to solve this problem. I will say current is my head, which is my first pointer, and I will say previous, and I will say previous is null. This is going to be my second pointer, and at the end of the solution I will return my previous pointer, which will be having pointed towards the node having element value as 5. That's my aim. And we will also need a loop here because it's an iterative approach. What I will do is, while current is not equal to null, keep doing some logic to reverse the linked list. So this covers the iterative approach aspect of it, and these are the two pointers that I will be using. I will try to cover the first iteration to explain the workflow, and then we just keep iterating until we have current not equal to null to reverse the linked list. let's say we have the first node pointing to the second node, and the second node right now points to the third node, but let's just consider this two for now. Let's not focus on rest of the linked list. And as we said here, current is my head. I will say current is my head, and I also have a previous pointer which is initially pointing to null as we initialize it at the start. Now here what I will do is I will use a temporary variable called as next, and inside next what I will put is current dot next. Now if this is my current, this was my current dot next as we start the sequence. Hence this is my next, and after I put this in a temporary variable, this is temporary. What I will do is I will say current dot next is equal to previous. When we started, my previous was null, so now current dot next will become null. As soon as we do this, please note that we had 1 pointing to 2, it was pointing to 2 here, and 2 pointing to something else. Now instead of pointing to 2, this will now point to null as we run this iteration. And then what we'll say is previous is equal to current. Now current, which was this one, if we say previous is equal to current, that means that this now will become my previous element, which is pointing to null as we just now saw in the previous step. So this is what we have, and we had kept this variable, temporary variable, to store our second node. And now what we will do is we will say current is equal to next, and when we say current equal to next, what we mean is this is my previous, and this now becomes my current, which was initially stored in a temporary variable. So this now is my current, and at the end of this iteration what we have is 2, which is pointing to something, and we have 1 which is pointing to null, and this is my previous. Please note we started with 1 as the current and current dot next as 2. This will be my new current. This is the outcome of the first iteration. We know this is right now pointing to 3, but I don't want to represent it as part of this iteration, just to simplify the visual representation. So this is pointing to 3 right now, which is pointing to something, but let's just focus on this aspect. Now when the next iteration happens, when we follow the same sequence of the steps, what will happen now is two will point to 1 instead, which was already pointing to null. So this is what will happen in iteration 2, and this will become my previous, and 3, which was the third node, will become my current, and we will keep moving forward with this current and previous pointers till we have current not equal to null. So until we reach the last node in the chain, we will be keep on doing this, and at the end we will be left with this previous pointer pointing to 5, and that's pretty much it, our solution. If we go to compute the time complexity of this, as you can see, we keep iterating with current and previous till we have nodes. As we said, current is not equal to null, and it will iterate as many times we have nodes. Because of that, the time complexity will be order of n. Now when it comes to space complexity, we have two pointers with us, which is pointer 1, that was current equal to hit, so this is order of 1, and this one is also order of 1 when it comes to space complexity. And we are using this temporary variable while we are overriding values in this loop. So this can also be represented with order of 1. Apart from that, this memory is, we have this existing nodes which are being overwritten in a sequence using a temporary swap variable here. Hence order of 1 plus order of 1 plus order of 1 is ultimately order of 1 itself. Hence the space complexity is order of 1, and that's pretty much it. Thank you. Please like and subscribe. Bye.